today a little bit. But what we have at the very top is just a teeny tiny example that says, and this, if you FOIL this out or use a box to multiply this out, this just gives you factored form. So factored form has little sets of parentheses, these two things multiplied together. If you would want to do a FOIL or a box on this, it would give you x squared plus 3x minus 10, which is what we would call standard form. So those are the two different forms. We're going to kind of flip back and forth between the two today. And so we're just going to practice a couple questions up here at the top. It's kind of an extension of what we did yesterday, but instead of me just multiplying two polynomials together, we're going to multiply three polynomials together, so it's very extra. Anyway, so we're going to have factored form in this first example. We're going to multiply it out and put it in standard form. So I have three different little binomials that I'm going to multiply together. You can do this however you want. This is my recommendation. I take whichever two are like on the far right and just do two at once. Don't try to multiply them all three together at once. It'll be really confusing. So just do two at a time. So I usually just do the two on the end. That might make more sense in a second why I did that. But I'm just going to multiply those together. So box or FOIL, whichever one you like better. Just a normal, I think of it as a double distributive property. If you want to draw a box, just draw a little 2 by 2. So I'm going to get, let's see, no, I just lied to you, 3x squared. X times 3x is 3x squared. X times 4, give me 4x. And then I'm going to do 5 times both of those terms in that last set of parentheses. So I'm going to get 15x plus 20. And now I'm thinking we might want a calculator today. So if you don't have one, you're welcome to grab one of mine. And mercifully, I have mine up here. Anyway, so I just multiplied the 2 on the end. If you want to draw a box, we should get the same thing. Usually you can combine some like terms when you do that in the middle there. I've got 4x and 15x, so that's 19x. Okay, now all I'm going to do, I have not multiplied yet by that x plus 10. So I'm just going to bring that down. And then this turns into problems like you guys saw yesterday. So again, if you like a box or if you like a FOIL, I'll tell you what, I did the FOIL at the beginning, so I'm just going to draw a little box. If you don't like the box, don't do the box. Do the little FOIL on steroids that we did yesterday. You got to multiply x by all three of the terms in that second set of parentheses, and then you also have to do that with the 10. So just multiplying this out. So remember, if you do x times another x, you're going to add the exponents. So if I do x times 3x squared, that turns it into 3x to the third. Just adds an exponent. X times 19x gives you 19x squared. X times 20 just gives you 20x. And then I'm going to go through and multiply everybody on top there by 10. So, and if you're doing the FOIL, you should get the same thing. This would be 30x squared. Dang, 190x. And 200. And then I'm just going to combine my like terms. Usually if you do the box, the like terms are going to be like diagonal from each other, like the plain x's and the x squared. Don't forget, when you are adding and subtracting, don't change exponents. Do not change exponents. That's only if you're multiplying. So I have a 3x cubed. That's the only one. And then I got 30 and 19. So 49x squared. And I've got 190 and 20. So that would be 210 x's. You get some kind of big coefficients on some of these. And then there's no other plain number besides the 200. So that would be it. I know it's a lot. It's just an extra step from what you did yesterday. Is anybody having a question? Okay, I would argue to you this is probably a little bit harder than the one I'm going to do next to this, but the one I'm going to do next to this has a little thing I want to make sure I draw your attention to. So I have x plus 4 times x minus 2, and that's squared. Okay, please don't forget, if something's squared, it's just being multiplied by itself. Do not distribute that exponent and write like x squared plus 4 or something like that, because you'll totally miss out on the middle term and screw that up. If you have a little set of parentheses with adding or subtracting, I have subtracting in here, just do me a quick favor, and we're just going to write that twice. Because it's squared, so it means it's multiplied by itself. Like if it was to the third, I could write it 3 times. I'm not going to give you guys anything like that. But just don't distribute an exponent. Anytime you have adding or subtracting inside the parentheses, just write it twice. And then I would just do this just like I did the last problem. Bless you. All right, I always just do the last two together first. You can do any two that you want to. I'm just going to do these two just real quick, like I did the last one. So I'm going to get x squared minus 2x minus another 2x and then plus 4. And you'll see if you distribute that exponent, you would completely mess up and not get that negative 4x as the middle term there. So you can't distribute the exponent in terms of like just writing x squared plus 4 because you miss the middle term and not get that correct. So that's just me multiplying those two, and then I just got to drag down the x plus 4, and then this turns into like a problem we were doing yesterday. So like I did the box on the last one, so we'll do our little foil on steroids on this one. So just x times all three of those things. You're going to get x cubed minus 4x squared plus 4x. It just adds an x or an exponent to each one of the terms when you multiply by an x. And then I'm going to go through and I'm going to multiply everybody by 4. If you like this method better, what I would do, I try to line up the like terms to help myself. So if I do 4 times x squared, I just put that underneath, like vertically underneath the other x squared term. It's actually going to cancel out here in this question. Then I'm going to do 4 times negative 4x, so it'd be negative 16x. I just write that underneath the other x terms. It makes it easier to combine. And then on the end, I got 4 times 4, so that's 16. And we get x cubed. These guys are opposites, so they're going to cancel out. 4 minus 16 would be, let's see, negative 12 x's, and then just a plain 16 at the end. And it doesn't ask us to label these like we were doing yesterday or anything in the direction, so that's just your answer, is just to change it from factored form to standard form. So these are standard form once you get rid of all the lovely parentheses, all multiplied out. Highest power of x first. Powers of x have to go biggest to smallest from left to right as you read it. Okay, now, does anyone have any questions? Okay, now, I'm going to go backwards from what I just had you do. I'm going to give you the standard form, and we're going to put it in the form with the little sets of parentheses. So we're going to go backwards here. There's nothing that should have 3 sets of parentheses. We might have a greatest common factor or something like that, but nothing that we would have 3 different sets of parentheses on. Okay, so in the directions, this is super important if you see this. It says factor completely. Generally speaking, if you see something like that, it probably means there's the greatest common factor that you can pull out, and then whatever is left, once you pull that out, can probably be factored further, which is the case for both of these questions. So if I look at this guy, I've got x cubed minus 6x squared plus 8x. Tell me what all 3 of those terms have in common. X. Okay, so this is like undoing a distributive property. We're just going to pull an x out in front. Now, like if I multiply, I add an exponent. So if I divide, I'm just going to take away an exponent. So this first term left over would just turn into x squared. The second term would be negative 6x, just a plain x. And then the x on the last one's going to go away, so you're just going to have a plus 8. So the deal is when you see this factor completely stuff, whatever is in the parentheses probably in most cases can be factored a little bit further, and I promise this one you can. So this is going to be, if you guys remember doing this, I'm going to multiply a times c. In this case, the a value is just 1. So c value would be 8 times 1, and I'm going to add to get the b value, which is negative 6. Now, both factors, this is just x squared, so both factors just start x and x. You just drop the squared, because x times x will give me x squared, and I just fill in the numbers with the 2 numbers that fit those requirements. Can you guys think of 2 numbers if you multiplied them together it'd be positive 8, but if you added them together it'd be negative 6? Oh, I heard like 3 people say it. Okay, negative 2, negative 4. Does not matter which one comes first or second. You could put the x minus 4 first or the x minus 2 first. It doesn't matter. Typically, if you did take out a greatest common factor that's just like a plain x, that would go out in front because that doesn't have any parentheses with it. So, but you could flip the order of these 2, and then this is your answer. Okay, now I'm just going to try one more with you guys here. This one is a little bit different concept. I have x to the 4th, just 2 terms here, minus 25x squared. What do those 2 terms have in common? X squared. Okay, so I'm going to pull an x squared just like undoing a distributive property. So now with my exponents, I'm going to take away 2 because I'm taking 2 out in front. So that x to the 4th, if you divide that, left over would be an x squared. So 4 goes down to 2. The other term is just going to be 25. Now, I don't know if you guys are going to remember this. This is called a difference of squares, and you can factor this. And you can actually use my multiply and add too. This would be multiply, it'd be to get negative 25. I don't have a b value here because I have no term with an x, so the two numbers would have to add up to 0. Can you think of two numbers if you multiplied them it'd be negative 25, but if you added them up they'd cancel each other out? Yes. Okay, either way, I'm going to put the plus 5 first and the minus 5 second, but you can flip those around if you want to. Same answer. There's your factored form. Is anybody having a question? The reason that we like factored form we're going to do on the back is because it helps you solve the equation. Because if you have the factored form, it's easy to pick out the zeros. Don't turn this over for 1 second. I got to tell you about the multiplicities. Okay, we're going to do these examples on the back. So we're going to have equations on the back. These are just expressions. They don't have any equal signs. We're going to have equations on the back. So what we're going to find are the solutions. They call those, for a polynomial, like they'll call it a 0 most of the time, or a root. We called them zeros when we were working in our quadratics unit in the last couple of lessons at the end there. But it says the value of the independent variable. Typically that's x. In a general question, we had like the height and time questions too, but typically the independent variable is x, that if I plug this in for x, it would make it 0. So like up here, if I had these set equal to 0 that we just did, like you'd tell me like this would be 0, this would be 2, this would be 4. Those are the zeros. This is just not an equation, so I'm not writing that, but that's all we're going to do. Now, if you have a 0 or a root, if you have a graph, you can actually see these where the graph crosses the x-axis if it's a real number. If it's imaginary, we'll do that later on. And then the other important part, the number of zeros equals the degree of the polynomial. If you guys remember from yesterday, like let me pull this back down, like this degree is 3, this degree is 4. It's just the highest power of x. And that's where this little thing at the bottom comes into play. So I'm going to write down a multiple 0 is, it's a solution or a root or a 0, and this is not a technical definition, but this is how I'm going to explain it, that counts more than once. So we're going to define that on the back better, but it basically, if you have to have the number of zeros to add up to your degree, there are some situations where you'd have a 0 that counts as more than 1. This will make sense in a second. All right, now what we call the multiplicity is the number of times a 0 counts, as I just was kind of referring to for the multiple 0. So that's what a multiplicity is. It's super easy to do. It's literally just you identify an exponent. I promise that's not hard. Okay, so we're going to do these on the back. Now, each one of these is an equation. So I did not have any equations in the front. We just started practice factoring because we're going to do that in a couple of questions at the bottom to solve them. These are already in factored form, so if you have to solve a polynomial equation in factored form, that would be lovely if it's in that format, because you could just figure out what would set the little parentheses equal to 0, and then you're good. So this is two things multiplied together to give me 0. And my solutions, which I'm going to write out here, literally all you have to do, and you don't have to write this out, but just take whatever's in there and figure out what you would plug in for x to make that 0. If it's got a number in front of the x, sometimes it's a little easier to make a little equation. I just kind of do it in my head, but for like that first one, to set that equal to 0, I would add 2 and divide by 3. For the second one, what would you plug into x plus 2 to make that 0? Like, well, if I had x plus 2, what would you plug in for x to make it 0? Just negative 2. Okay, now here's the deal with that thing I mentioned on the front with the multiplicity, right? I have two answers to this question, okay? This is x to the, or this has got a 4th power on it, right? So this negative 2, I'm going to write m for multiplicity, would count I know this is weird, but it counts as 4 answers. And you're probably like, what the heck, why would I need 4 answers? You're not doing this. Okay, I'm just going to do it on my paper here real quick. If I were to actually take and multiply out what is there, I have that x plus 2 4 times, right? If you wanted the very first term, if I were to multiply this out, I would just multiply like literally the first thing in each one of those to get that, to get the degree. This would be 3x, this would make it squared, third, fourth, fifth. So this would be the first term if I multiplied that all out. So this would need 5 answers based on what I was just telling you, that the number of solutions matches the degree. So 5 answers, this is 1. This one counts as 4 different answers, so this would be 5 solutions then. So that's what the multiplicity is. You don't always have that, but that helps add up to the degree if you do have not as many zeros as you have little sets of parentheses there. So any exponent is just a multiplicity. That 0 counts that many times. So like all you have to do, just set each one of these equal to 0. Before I do that, anybody know what the highest power of x would be here if I multiplied this all out? You're so close. It would not be 5. It would be 6. So you'd have like the 2x here. This x plus 6 would be 3 times. This x plus 7 would be twice. So I'd have 3 here, 2 here, and the 1 here. So this would be like the first term if we multiplied it all out. So I'm supposed to have 6 answers here. All right, so here's how this works. This one, it's a little tricky. If I set that equal to 0, right, we'd subtract 5 divided by 2, so negative 5 over 2. There's no multiplicity there. That just counts once. X plus 6, I'd plug in negative 6, but that has an exponent. That has a multiplicity of 3, so that one counts as 3 zeros, right? I'm supposed to have 6, so I've got 1 and 3 more, so this would be 4. And then here, we'd plug in 7. That has an exponent. If it has an exponent, it just means it has a multiplicity, so that one counts twice. And so there you got 2, 3, and 1 more, so you got 6 total, even though they're not 6 different numbers. I know that's a little bit weird, but the multiplicity is just the exponent. Now the exponent has to be on the parentheses, because you're going to see this in the next question. All right, now if I multiplied this all out, which I'm not asking you to do, I'm just going to ask you to think about it for a second. You just take the first term in each one. So I would have negative 2, this would be x squared, another x squared would be to the 4th, and another x, so this would be negative 2x to the 5th. That would be the first term if I multiplied this all out. So I should have 5 answers here. Just the first term in each little set of parentheses. If you multiplied those all out, that will give you your first term. That'll tell you how many answers you're supposed to have. So this one's got kind of some interesting stuff in it. Right here, I would just plug in on the end there negative 5, right? Just one answer. What would you plug in? I don't have parentheses, but I have negative 2x squared. What would you plug in there to make that negative 2x squared equal to 0? And if you're not sure, you could literally just do it like, if I took negative 2x squared and set that equal to 0, that would wipe the whole thing out. What would you plug in for x to make that true? 0. Yeah, like if you divide by negative 2, that'd be 0, take the square root of 0, 0. So this is 0, but I know I don't have parentheses here, but that x out in front, see how it has an exponent of 2. So that actually does have a multiplicity of 2. So that counts twice. The negative 5 counts once. I'm supposed to have 5 answers, so I need 2 more. Now, this one in the middle is a little weird. This does not have a multiplicity because that exponent is not outside the parentheses. So whatever's inside the parentheses, if that was equal to 0, that would cause the whole thing there to be 0. I'm going to solve this tiny little equation real quick. We're just going to use square roots. So I'm going to add 64. And then how would I solve that? Square root. If you introduce the square root, what do you have to put in front of your answer? So this is 2 different answers. And what would you put for this? 8. So this is negative 8 and positive 8. So that's 2 different answers. So I've got 1, 2, 3, and this 4, 5 counts as 5. I know this is a little bit weird, but the multiplicity, if it has one, It's just going to be an exponent outside the parentheses. This one, the exponent's inside the parentheses, so I just solved that little equation is all I did. Is anybody having a question? Okay, now I'm going to give you the answer, and you are going to tell me the little factored form. So these are the zeros. So I'm just going to start each one of these in this example out with a 0 equals. We're going to just write an equation. So if I told you 4 was an answer, what little set of parentheses would go with 4 being an answer? I heard somebody say x minus 4. Just the opposite. So like if I do x minus 4, like if I plug in 4, that makes that 0. What would your little parentheses be for negative 3? X plus 3. It's just the opposite. What about the 2? X minus 2. Done. That's all you have to do. Okay, now this is a little tricky. What if I told you 0 was an answer? What would you put for that in the equation? Just x. Exactly. Just an x. Okay, then what about positive 3? X minus 3. Now, these I always think are tricky with the fractions. So the fractions, think back up to like these questions up here. Like I had 3x minus 2 and we got 2/3. Or over here we had 2x plus 5 and I got negative 5 over 2. So if I have a positive number, I know that the actual little factor is going to be negative. If you have a fraction, just kind of try and think through backwards. So what I would need to do to get 2/5, I would need to add 2 and divide by 5. So the 5 is going to go with the x, and then the 2 is just going to be subtracted in that situation. So whatever's in the denominator, if you have a fraction, that's going to get multiplied by x, and whatever's in the numerator, the opposite of that is what's going to go to the side to write that factor. Because if I set that equal to 0, I'd add 2 divided by 5. So I'm just kind of working that backwards. All right, so like if I have negative 1/2, anybody want to try it? What would you write as negative 1/2 as the little, it'll be kind of like this. 2x plus 1, good. Because you'd subtract 1, divide by 2. All right, now this says 9, but then it says with a multiplicity of 2. All you have to do for that, just if I gave you 9, hopefully you'd tell me x minus 9. If it tells you in multiplicity, just put that number as an exponent on that little set of parentheses is all you have to do. So if it gives you multiplicity, just put that as an exponent. If it doesn't give you multiplicity, just put normal little set of parentheses. That's it. Okay, now we're going to tie this all together. I'm going to have you guys factor these at the bottom to actually solve. So these are not expressions, these are equations. So we're actually going to get the answer to the question here. All right, what do all the terms in x to the 6th, x to the 5th, and negative 12x to the 4th have in common? X to the 4th, right? All right, now left over, you'd have x squared minus x minus 12. I'm going to take 4 out of each exponent. Sorry, I should have written this. I can tell right away from that x to the 6th that this should have 6 answers. It's in standard form, so I can see right away I should have 6 answers to this question, but we can count the multiplicities in this. All right, tell me, I need 2 numbers. If I'd multiply them, it'd be negative 12. Sorry, I'm going to bleed into the next question. If I added them, I would get negative 1. You got 1 and 12, 6 and 2, 3 and 4. So I got to multiply to get negative 12, add to get negative 1. It's got to be 3 and 4. Which one has to be negative? The 4. All right, so x minus 4, x plus 3. That order that you put those in does not matter. Okay, we're supposed to have 6 answers to this question, right? Negative 3 is one of the answers. 4 is one of the answers, so I got 2 answers. Now, because we pulled this x to the 4th out in front, this is 0, but it has a multiplicity of 4 because of that exponent. So that counts as 4 answers, and then I have all 6. Does anybody have a question? I know it's weird. All right, let me have you guys look at this one. Each one's just a little different. All right, so I know right away, this is x to the 5th. The degree matches the number of answers I'm supposed to have. So I should have 5 zeros, answers, roots, whatever you want to call them. What can I take out of x to the 5th and 49x to the 3rd? X to the 3rd. So we're going to take 3 away from each of these exponents. So this is going to be x squared minus 49. And I got to have, for this one, so difference of squares, or tell me two numbers that multiply to give you negative 49 and add up to 0. 7, negative 7. So one of them's x minus 7, one of them's x plus 7. Okay, doesn't matter the order you put those in. So one of my answers is negative 7. One of my answers is positive 7. I'm supposed to have 5. And then here, because we pulled out an x to the third, this is 0, but it has an exponent, so it has a multiplicity of 3. So that counts as 3 answers. So then I have 5. 3 with that 0, and then negative 7 and 7 give me the other 2. Okay, we have one last problem. What do 2x to the third, 12x squared, and 18x all have in common? X at least, anything else? 2. Alright, so I'm going to take a 2x out in front of each one of these. Alright, all that's going to do, I'm going to divide the coefficient by 2, and I'm going to take 1 away from the exponent. So this first term will just be x squared. The next one would be negative 6x, and then the last one, the x's, I don't know why I just wrote 3. Pretend I did not do that. The last one will be 9. The x's cancel out. I apologize. Okay, now, oops, I should have written this down. At the very beginning of the problem, I see I have 2x to the third, so I know that this question automatically should have 3 answers because that's the degree. Alright, tell me two numbers. We're going to multiply to get 9, add to get negative 6. Negative 3, negative 3. Now, right, if they're matching, which they are, we can squish it together. Write it as x minus 3 squared. Okay, now, here's the biggest mistake people make, especially if they pull a number out in front. What would you plug into 2x to make that 0? What would you plug into 2x to make it equal to 0? Just 0. Don't put a 2, don't put a negative 2. That's what, if there's a number out in front, that confuses people. But if I just have 2 times x, to make that 0, you would plug in 0 for x. 2 times 0 would be 0. There's no multiplicity there, so just 0. That would just count once. However, the 3 that I'm going to plug into x minus 3 has the exponent, because we wrote that twice, I just squished that together, but it just means it has a multiplicity of 2, so that counts as 2. So I've got 2 here, then there's 3, and I have all 3 of my answers. Is anybody having a question?